Hello. Can everybody hear me? Cool. So, before I begin, I'd just like to ask a really quick question. Could you put your hands up if you've ever been so scared in your life, so frightened that a little bit of pee has come out? Keep your hands up. Okay, that's about 50% of the audience. And hopefully, by the end of this talk, I will have increased that number a little bit. Because today, we're talking about web security and hacking. My name is Asim Hussain. On Twitter, you can find me at JawAche. I blog about JavaScript and Angular on my site, codecraft.tv, and I'm something called a cloud developer advocate at Microsoft. So I work on the Azure team, or with the Azure team, and yeah, talk about cloud and security and JavaScript and a bunch of those things. But to begin with today, I want to tell you a story. The story of my first startup. It's called Event Sushi. It was an event site that aggregated events from a bunch of different places, from Meetup, Facebook, Last.fm, a few other places. At the time, I used to work in investment banking. My career was going very well. It was good money. But this was just a side project. But, you know, it was going slightly okay. Very, very slightly. So I did what everybody does in this situation, and I quit a really good job, well-paying, to work on something quite risky. And I told you I was in investment banking, so of course I was very, very arrogant. At the start, I had investors who were interested in investing in me, but I was like, no. This is going to be $1 billion startup. I don't want your money. I want 100%. So I said no. So you can probably guess where I'm going with this. 6 months later, the product wasn't $1 billion startup. I was running out of money. This was my money, not investors' money, my money. I didn't have enough money to pay rent in 2 months. So I then started going back after the same investors, saying, hey, look, I'm interested now. But they could tell that I was now desperate, so they were backing away. They didn't want to invest. Apart from one guy. We've been talking for 6 months. He liked me, he liked the product, and he said, Asim, okay, look, give me another demo in 7 days. Show me what you've built recently, and then we'll talk. And it was a good chance he was going to invest. So I was like, yes, it's going to survive. But then, 48 hours before the meeting with the investor, I got emailed by Linode. So Linode were the people I was using to host my website. And they said, look, Asim, it looks like your server's been compromised. We can see it's making hundreds of requests to other servers, and if you don't solve the problem in 24 hours, we're going to shut you down. So in 48 hours, I was going to have a life-saving meeting with an investor, and in 24 hours, I was going to get shut down by Linode. So I panicked. I jumped onto the server, I started looking around, and to cut a long story short, I definitely got hacked. Definitely got hacked. I found stuff in the temp folder. There were scripts that were running that was doing brute force attacks on a bunch of IP addresses. And I was wondering, like, what is going on? How did I get hacked? And then, after a bit more investigation, I saw that PHP was running. I thought, why is PHP running? I'm not a PHP developer, right? Then I remembered when I first set up the server, I'd installed WordPress, okay? I got rid of it straight away, but I forgot to remove it from the start script. So when the server rebooted, PHP started, and that's how the hackers got in. So, I cleaned everything up, removed it from the start script, contacted Linode, they were happy, had the meeting with the investor. He invested, The startup still failed, but I had some money. So I'm no fool. I'm not an idiot. I took security very, very seriously. When I set up that server, I'd followed all of the instructions. I'd just forgotten one tiny, tiny, tiny small thing. So I think the lesson is that if it can happen to me, it can happen to you. So you might guess that I love stories. So today I'm going to talk to you about hacking, but through a series of 4 different hacking stories. Some of these stories are going to be specific to Node, some are going to be more general web development. Each story is going to have a moral at the end, a lesson to learn, and perhaps some steps you can use to protect yourself. And I think to begin with, let's just start off by breaking down exactly how I think I got hacked on Event Sushi. Just give me a second. But first, let me just explain a few terms. So a vulnerability is a hole in your security, a weakness. So for instance, not setting up a firewall is a hole in your security, it's a vulnerability. An exploit is a tool or a piece of code or even just a sequence of commands that you execute which takes advantage of a vulnerability to do bad things. Okay? So who here has heard the term zero-day exploit? Yeah? So a zero-day exploit is one that nobody knows about yet. Okay, it's a secret. But once a zero-day exploit is found out about, is known about, perhaps a white hat hacker has discovered it and informed the company, it's not called a zero-day exploit anymore. It might be called a 1-day or a 30-day or a 6-month exploit. You don't really call it that, but just a way to think about it. Basically, once a zero-day exploit becomes known, the clock starts ticking. So let me ask you a question. How hard do you think it would be to get a hold of a zero-day exploit? Pretty hard, right? No, you need to be the right kind of person. You need to know the right kinds of people. There was a study done, I can't remember when, maybe last year. They estimated that a zero-day exploit is sold for about $250,000 each. They're usually sold to criminal organizations or state-run hacking organizations. But how hard do you think it would be to get a hold of a 6-month-old exploit? Not very hard. In fact, it's actually really, really easy. You can just find it on the internet. This is one website, ExploitDB. There's a bunch of sites. This is just one of them. And it's pretty easy to use. Type in PHP, it's got a captcha, hit search, and take a look at this. These are all the exploits it's found. Look at the date. We're still in 2017. PHP isn't very secure. Okay? I can tell we've got some PHP developers in the audience. So who knows this? Yeah, Mr. Robot. So we all like to believe all of our hackers are like this. Black hat, mysterious, geniuses. And I think we like to believe that because it makes us feel better when we do get hacked. I mean, if we got hacked and you can just say, how am I supposed to protect myself from Mr. Robot? Come on. But Mr. Robot didn't hack me. They didn't use a zero-day exploit to get into my server. I was running a really old version of PHP. My attacker Googled how to hack me and followed instructions. It's not hard. In fact, it's even easier than that. I mean, we're all developers in this room. How many of us have spent a day writing a script to automate something that takes us 2 minutes? We all do it all the time. So why wouldn't hackers do the same? And they do all the time. This is an automated tool called Metasploit, which you can basically point at a website and it will scan it for known vulnerabilities. And it also has a bunch of plugins in it, and you can install other plugins that you want that will also perform automated attacks as well. There's another study that estimated about 27% of all websites in the world can be hacked automatically. So, what can we do? What can we do to protect ourselves from this? There's not much you can do about zero-day exploits. Okay, you can't protect yourself from something you don't know about. But you can defend yourself from the unknown. All you've got to do is make sure you keep all of your software updated all the time. Make sure you keep the web server updated. Oh, the operating system itself, make sure you keep that updated. Oh, I'm using Nginx, got to make sure I'm keeping that updated. And oh, my database, got to make sure I'm going to keep my database updated all the time. And oh my God, I'm using NPM, so I need to make sure my NPM modules are updated all the time. Also, I need to listen to security bulletins as well and make sure I patch my software as soon as anything gets updated. It's actually not that easy. And your job isn't to do all of that stuff. Your job is to write functionality, is to write software for your end users. And that's why, after I got hacked this one time, I started to exclusively use PASs. Just to explain what a PAS is, back in the old days, or even now, you can still do it now, if you want to deploy something, you had to have some sort of on-premise hardware. You'd buy a server, you put it in your own room, or you'd go to a server farm and they would just put it in there for you. But you're in charge of the hardware. If the hard drive fails, it's up to you to fix it. But then you're also responsible for the operating system, keeping that updated, and the web server, and the database, and everything else. And your application as well. You've got to obviously keep that updated. And then we have infrastructure as a service. So that's stuff like, Linode, Amazon Web Services, Azure, Google, we've all got stuff like this. And that's basically where you get a VM. So somebody else is responsible for looking after your hardware. If the hard drive fails, they fix it. But you still have to handle the operating system, the web server, the database, everything else, and of course your application as well. And then we have PaaSes, Platform as a Service. So they handle the hardware. They also handle the operating system, depending on the PaaS. They'll handle the web server and the database and everything else as well. And you just focus on deploying your application. And the thing with PaaSes is they've got teams of people, teams of security experts, and all their job is, every single day, is making sure there's no security holes, patching every vulnerability as soon as it gets released. Okay? And there's a bunch of them out there. I work in Microsoft, so we've got one called Azure App Services. Google's got Google App Engine. We've got Amazon Beanstalk, and there's another one I've used called Heroku, but there's a bunch of others as well. So, and if you're still kind of a little bit, I know there's a lot of people who are kind of used to using VMs and installing all their own software and managing all this stuff themselves that are a little bit suspicious of what I'm saying. Who's heard of the Equifax hack that happened earlier on this year? Okay? It's the largest ever hack in history. About 200 million people's records were taken. Equifax is $1 billion company, about 10,000 employees. Did the hackers get in through a zero-day exploit? No. They got in through a known exploit of Apache struts, which is a Java web framework. The patch to the fix was available for 2 months before the hackers got in. All that Equifax had to do to defend from this attack was apply an update. They just never updated their software. Largest hack in history. Oh, and if one of the coolest things about Azure that I like is something called the Azure Security Center. So as far as I can tell, and correct me if I'm wrong, no one else has got this yet. So one of the problems with detecting attacks is there's loads of different signals all over the place. And if you just alerted on every single signal, then there'll just be too much noise. You start ignoring the alerts. So to solve this, we trained an AI. So we took a whole load of attack data. We said this, or a whole load of data. We said these signals are from definite attacks. We trained up an AI. So now we feed in all of your signals through this AI, and we alert you only when, well, the AI alerts. Now, it's not perfect, but it's easy. Just switch a button and it switches on. And I'm lazy, so I just like to switch it on. Does anybody know this show? Nobody? Don't worry about it. I think I'm one of the 3 fans of this show in the world. It's called It's Always Sunny in Philadelphia. Very funny, I recommend it. I think they're on the 11th season now. And this is one of the characters called Charlie Kelly. And he plays the dumbest guy in the show. He cleans the toilets and kills rats. That makes sense if you watch it. But one of the things is he thinks he's a lawyer. So whenever he gets into trouble, he always represents himself in court very badly, represents himself in court. So my closing arguments are this. Thinking you can create a secure platform to host your application when you're not a security expert is like thinking you can represent yourself in court when you're not a lawyer. So did I scare anybody just yet? No? You're all pretty calm, I can tell. I can't really see the fear in you, I can't smell it. Maybe the next one. So, in the UK, I'm based in the UK. In the UK, when you register a company, you have to register it with the government, with something called Companies House. So if you actually went to Companies House website and searched for my company, Del Revo Limited, you would find me here. And this is an actual company in the UK. This is the address. Yeah? And what this is an example of an attack. Something called an injection attack, something specifically called a Sql injection attack. And the point of kind of any injection attack is to run untrusted code in a trusted environment. So basically, to trick you in running this Sql code here. So how does that work? Maybe you've got a script which gets all the names and you want to grab some details from your database. But if you actually put the name of the company in here, you'd end up with something like this. Select star for a company where name is equal to nothing. Drop table, companies. And then a comment. You might be saying, so what, Asim? I've backed up my company's table. I'm not really too bothered about this. I'll just restore it. But then, drop table isn't the only command you can run on a database. And just like a lot of things, there's automated tools which help to attack. So look at this one, SQL map, automated SQL injection and database takeover tool. Takeover. So what does this do? Well, you would run it. Is it running? There we go. It's a Python script. Pass it some endpoint. This is an API endpoint which has an injection attack vulnerability. It first scans it, figures out it's MySQL, the version number, different aspects about the database. And then, OK, now we know it's MySQL. Let's try it with a common set of passwords for MySQL. So it's brute force attacking. And there we go, found the password for it. Now let's have a list of the databases. Let's list all the tables. Let's now, what's it going to do now? Oh, yeah, let's dump a table. Let's dump the users table. OK, no biggie. But MySQL also lets you do things like OS shell, which lets you run commands on the server MySQL is running on. So we're running ls, and now we're catting the password file. All from one vulnerability in your script. So in about a minute, in about a minute, we ran that script and got the etc password file from your server. What's the moral of this story? I think the moral of this story is never assume that your inputs will arrive in the format that you expect. Okay? And the kind of solution for this, and this is kind of general across a lot of problems or a lot of whole vulnerabilities in this space, is to do something called sanitization. Okay, you've got untrusted import. That name was untrusted. Someone else was providing that, so you have to sanitize it. There's a bunch of different methods of sanitizing on Node. For SQL, you can use SQL string, where you pass it some untrusted SQL. It will escape stuff that it knows is dangerous and let you run the output command, output SQL. And if you're using Azure SQL database, we also have detection capabilities where we can detect SQL statements that we know are suspecting are basically injection attacks, and we alert you on it. We don't stop the SQL from being executed, we just alert you on it, and it then feeds in to the AI as well. So you can actually see in a chain, oh, we think you got Sql injection attacked, oh, we think that somebody logged into your server, and you can follow this path through your system. So that was the second story. How are you feeling now? A little bit more? Well, I did just show everybody how to completely take over a server in a minute using, OK, you get a tough crowd. Well, I don't know, maybe the next story. Anybody heard of this company? No? I still use Perforce. So this is GitHub. We all know GitHub, hopefully. And GitHub has something called a bug bounty, where basically they will like pay you if you find a security hole in their software and you tell them about it first. You tell them about it privately and you give them a chance to fix it before you tell everybody in the world. So there's a really great exploit found by this user called Orange Sai. This is their Twitter. Follow them. I think they're posting some really interesting stuff. And it was with GitHub Enterprise. And they basically found a way to run any command on a GitHub server, the server itself. Okay? And they did this by chaining a number of smaller exploits together into one really big exploit. And I really liked it because it reminded me of like a heist movie. You know movies where they rob a bank? This story really reminds me of something like that. So I'd love to share it with you. So we know webhooks, or maybe we know webhooks in GitHub, where you can set up GitHub so when you do a git push, it does a post to some endpoint that you define. Pretty straightforward, right? But what if you set up the webhook as localhost? What would happen then? Well, then when you do a git push, behind the firewall, it would then do a post to something internal to the server. Remember, you can have localhost with a port number, so you can post to any process running on that same machine. But this was GitHub. They're no fools. They were using a sanitizer because that is untrusted input. And that sanitizer knew that localhost was a potential problem, so it would strip it out. But forgot about 0. Okay, on some servers, 0 would also point to localhost. So then, okay, found a way in. So now we've got one small vulnerability where you can do a git push and post to some process on your server. But what can you actually do with that? Well, the server was also running Elasticsearch. You know Elasticsearch? That runs on port 9200, and if you do a HTTP post request to this port and this endpoint, it shuts down Elasticsearch. But it's not a biggie. It's not the biggest issue in the world. So then started looking for another vulnerability to chain onto this. Started looking at the code and found this. Okay, so I know this is Python. Don't worry about it. I'll take you through it. So the server was also running another process called Graphite, which is a Python process that lets you do kind of charting and things like that. And it's open source, so it's checked into GitHub. So on GitHub, he found the source code for it. And then this was one of the functions that gets called on an API request. And just to take you through what this is doing, it gets the URL from the query parameters, gets the path, and then does a GET request to that path. There's a GET request to that path. So, what are we talking about here? Well, now if you set your webhook to this URL, 800 is Graphite. When you do a git push, it will post to this endpoint. That endpoint is that send email function. It will take this URL and then do a GET request. So all that it's done is they've turned a post into a GET. A post into a GET. On its own, maybe not such a big deal. But the actual method, the actual library they're using to make that request is called HTTP Connection. It's a Python library. And that has a known vulnerability, something called carriage return line feed. So carriage return, the \r, is how you did new lines in Windows, and \n is new line everywhere else. So, but if you converted that to hex, it would look like this, ODOA. So now, what happens when you make a GET request to this? Okay, so when converted into the protocol, it might look like this, but HTTP connection library will convert these to new lines, and then we're sending this. Okay. So, what is HTTP? What is it? What is HTTP? HTTP is you open up a TCP connection to this host and port, and then you're sending it a bunch of strings. And if that host and port recognizes those strings, it goes, oh, this is a HTTP connection. This is a HTTP message. I know what to do. But if it gets something that doesn't look like HTTP, it's just going to, oh, this is a malformed message. It's going to kick it out of the way. Right? That's what's happening here. OK. So what? You can send a malformed HTTP message to the server. But what if you did this? OK. That port is memcache. Now, if you try to do a GET request to this, you actually end up sending a HTTP message like this. Again, we're opening up a TCP port to memcache. Memcache doesn't know what this means. Oh, it's back. Memcache doesn't know what the first line means. It's just going to ignore it, right? The second line is memcache understands this. It knows what this is. This is setting the key, the value data, into the key. So it will do something with that. It will then ignore this line and this line and this line. It doesn't know what these are. Okay? What have we done? We've done something called protocol smuggling. Okay? In a HTTP message, we've managed to smuggle the memcache protocol, and so now we can set data in memcache. Oh, I forgot I had these lines. OK. So as developers, we all like to store stuff in memcache. We store some code, serialize it, store it in memcache, deserialize it, execute it, we're happy. But we're all pretty lazy people, so we probably don't do that serialization manually. We probably use a library where you pass it an object, serializes it for us, stores it in memcache, we take it back, the library unserializes it, and we execute some code. But now, we can set some data in memcache. So, as a developer, you're going to serialize your object, you're going to store it in memcache, and later on you're going to deserialize your object, but you're not deserializing your object, you're deserializing my object. You're going to execute a function. You're not going to execute your function, you're going to execute my function. Okay? I'm looking through the keys in the memcache, found this. So when you serialize a bunch of objects, you might, depending on the library, it might store the name of the class which is getting serialized. So they were using deprecated instance variable proxy. Instance variable proxy had a known vulnerability, so they put deprecated in front of it, but they still used it. So then it basically had a vulnerability where if you deserialize an instance of instance variable proxy, you can execute a command. So then, this is what the eventual webhook looks like. You've got the first one, so that simple post, gets converted into the second one's a get. Then this is the memcache key, so you can do set, that's the key. This is the deserialized data, and I can't remember where it is, somewhere in here. This is it. This is the command. When we deserialize this object, the ID command gets run on the server. So this is what they used to prove their case and get the money. Example of it working. You go to your profile, click on a repository, settings, add a webhook, runs a script to get the eventual name. Okay, gets the webhook URL, puts it in, gets ready to listen to any commands that get run on the server, and then to run that thing, just basically does a search, any search. That's going to request that data from memcache, the deserialization, then runs the ID command on the server. The moral of the story: big exploits are made from smaller exploits. Okay, we like to think our attacks come in through one big giant security hole, but they don't. You chain multiple smaller exploits together. So, if you find a vulnerability in your software and you think, it's not that big a deal, now fix it, because the GitHub's vulnerability, the only thing they had in their code was pretty small. How are you feeling now? A little bit more? OK, I've got to rush through the next one, but we'll go through it fast. All right. What does this code do? It takes your environment variables, gets a string of your environment variables. OK. What does this code do? Why is my server there? Oh, if you ran this code, it looks like it would take all of your environment variables and post them to my server. What if I told you I could make you run this code on your server? Who here puts private things in their environment variables? I do. Yeah. OK. Maybe this makes it clearer what this is. I should get an extra minute for this. Maybe this makes it clearer. It's some sort of setup script. In fact, maybe this makes it clearer. It's actually an NPM module. And this is a setup script for an NPM module. If you install this NPM module, you would send me all of your environment variables. OK, you're probably saying, Asim, why would I install your NPM module? Who saw this? It's about almost 2 months ago now. So Kent Dodds had a NPM module called crossenv. And they found that somebody else had created their own crossenv module. The real one was cross-env. The fake one was cross-env without the hyphen. This is downloaded 1 million times a day, by the way. So if you installed crossenv without the hyphen, you are sending your environment variables to somebody, to a hacker. How many times have you sat there and can't quite remember the NPM module names? You try it without the hyphen, and you're like, yeah, it worked, great. That's what happens. So the moral of the story is that we're a little bit too trusting, OK? And I think maybe it's because it was open source. We kind of trust open source data. We don't really question it. Now, NPM have taken down crossenv. They've got rid of all the ones that they could find associated with that account. But you can't really protect yourself from that. OK? What you can do with NPM now is you can have something called scope packages. Basically, you can own the scope, and then only you can publish things under it. That's a solution to you stopping yourself getting typo spotted on, which is what that's called. But it doesn't stop you from accidentally installing something like crossenv. So you just need to keep your mind clear on that one. Just in summary, OK, what are the takeaways? Stop pretending. Stop pretending that because you spent a few minutes thinking about security, that you can create your own platform to run software and use the PaaS. Don't assume the inputs will come in the format that you expect. Sanitize. Don't think that there's just a small vulnerability, I can ignore it. Fix it. Don't trust anyone. And I don't have a solution for that, so there's a unicorn. And that's it. If you do want to know a little bit more, my colleague has a course on Node.js security. I'll post up these slides on Twitter in a second, so if you want to follow me at Joake. And then I'll post up all the slides, and I'll have links for everything that I've just mentioned in this course, in this talk, including all the links to all the vulnerabilities and things I mentioned. And that's it. Thank you very much.